Imagine a reality where every quantum event, every fork in the road, splits the universe. In this grand tapestry of existence, countless parallel worlds unfold, each representing a different outcome. This mind-boggling concept is the many worlds interpretation, or MWI, of quantum mechanics. It suggests that our universe is just one of many, constantly branching out as quantum events occur. The MWI is not just a science fiction trope, it's a serious contender in the ongoing quest to understand the fundamental nature of reality. It challenges us to reconsider our place in the cosmos, suggesting that our experiences are but a tiny sliver of a much grander, multiversal reality. The idea of parallel universes is both exhilarating and bewildering. It opens up a Pandora's box of questions about identity, choice, and the very fabric of existence. Let's delve into this intriguing interpretation, exploring its origins, its implications, and the debates it continues to spark. At the heart of the MWI lies the baffling world of quantum mechanics, the theory governing the behavior of particles at the atomic and subatomic level. In the quantum realm, particles exist in a superposition of states, meaning they can be in multiple states simultaneously. It's only when we measure a particle that it collapses into a single, definite state. The MWI offers a radical interpretation of this phenomenon. Instead of the wave function collapsing, it suggests that all possible outcomes of a quantum measurement actually occur, but in different, non-interacting universes. For instance, if you flip a coin and observe heads, the MWI posits that in another universe there's a you who observed tails. This continuous branching creates a multitude of parallel universes, each representing a different path taken by the universal wave function. It's a dizzying concept, implying that there are countless versions of ourselves, each living out different scenarios based on the probabilistic nature of quantum events. The many worlds interpretation was first proposed by Hugh Everett III in his 1957 doctoral dissertation. At the time, the prevailing Copenhagen interpretation of quantum mechanics, which proposed the collapse of the wave function upon measurement, was widely accepted. Everett challenged this view, arguing that the wave function never collapses. Instead, it evolves continuously, encompassing all possible outcomes of a quantum measurement. His theory, initially met with skepticism, offered a mathematically elegant and deterministic alternative to the probabilistic nature of the Copenhagen interpretation. Despite initial resistance, Everett's ideas gradually gained traction, particularly among physicists seeking a more intuitive and consistent understanding of quantum mechanics. His work laid the foundation for decades of research and debate, shaping the MWI into a prominent, albeit controversial, interpretation of quantum mechanics. Untangling the threads. Analogies to grasp many worlds. The concept of multiple branching universes can be difficult to grasp. Analogies can help to visualize this complex theory. Imagine a game of roulette. When the ball lands on a number, the many worlds interpretation suggests that universes split, with each universe reflecting a different outcome. Another analogy involves choosing a path at a fork in the road. In the many worlds interpretation, both paths are taken, but by different versions of you in separate universes. Each choice, each quantum event spawns new realities. These analogies, while simplified, illustrate the fundamental idea behind the many worlds interpretation. Reality is not a single, fixed timeline, but rather a constantly branching tree of possibilities, where every quantum event generates a new branch. A philosophical labyrinth, pondering the implications. The many worlds interpretation doesn't simply challenge our understanding of physics, it plunges us into a philosophical labyrinth. If every quantum event spawns a new universe, what does this mean for our concept of self? Are there countless versions of us, each living out different lives? The many worlds interpretation also raises questions about free will and determinism. If all possible outcomes occur, is our fate predetermined, simply playing out in different branches of the multiverse, or do we retain some semblance of choice within our own branch? These questions highlight the profound philosophical implications of the many worlds interpretation. It forces us to confront fundamental questions about identity, choice, and the nature of reality itself, questions that continue to be debated by physicists and philosophers alike. are evidence and skepticism, navigating the scientific debate. Despite its growing popularity, the many worlds interpretation remains a topic of debate within the scientific community. One of the main criticisms is that it is difficult, if not impossible, to test experimentally. The non-interacting nature of the parallel universes makes it challenging to gather empirical evidence. However, proponents of the many worlds interpretation argue that its elegance and internal consistency make it a compelling interpretation. They point to the theory's ability to explain quantum phenomena without resorting to wave-function collapse, a concept that many find arbitrary and unsatisfying. Conclusion: the enduring allure of many worlds. The many worlds interpretation, despite its inherent strangeness and lack of definitive proof, continues to captivate the imagination of physicists and the public alike. It offers a radical and thought-provoking perspective on the nature of reality, suggesting a multiverse teeming with infinite possibilities. While the many worlds interpretation remains a topic of debate, its enduring appeal lies in its ability to address fundamental questions about quantum mechanics and the universe. Whether or not it ultimately proves to be correct, the many worlds interpretation serves as a testament to the boundless capacity of the human mind to explore the most profound mysteries of the cosmos. It reminds us that the universe, in all its complexity and wonder, may be far stranger and more marvelous than we ever imagined.